This is an automation car that we use. The problem statement is how this automation car can avoid the obstacle. This car has integrated by an ultrasonic sensor to detect the obstacles and avoid it with its actuation system by using Raspberry Pi microcontroller. This obstacle avoiding car can become a prototype for develop future autonomous car or autonomous wheelchairs which are benefit to our country. This is the list of material for obstacle avoiding car. Considering less number of components and cheaper price, we have discussed together and decided to purchase it as our functional machine in this project. The number of components are 11 and total price is around 85 ringgit. Here is our mechanical design of obstacle avoiding car in our EMC311 project. We have designed it by using CAD designing software SolidWorks version 2018. This is another view of our obstacle avoiding car. From this diagram, you can observe there are total 11 parts or components in this obstacle avoiding car. Each component has its own function. The components are 2-wheel, motor or gear motor, caster wheel, base, Raspberry Pi 4 Model B, motor driver, battery and battery holder, container, a power bank, an ultrasonic sensor, and a brake ball. This is the exploring view for obstacle avoiding car and show the ways for assembly whole products. This is an electrical schematic diagram of obstacle avoiding car. We can observe that the ultrasonic sensor is connected to Raspberry Pi 4 Model B and the motor driver. Two motors and the battery are connected to motor driver, while Raspberry Pi 4 is connected to motor driver and ultrasonic sensor.
So now we'll do the assembly of the obstacle avoiding car. We assemble it according to the mechanical drawing that we have done earlier using the Keat software. After all the parts have been assembled, now we will do the electrical wiring. We do the electrical wiring by following the electrical schematic diagram that we have done earlier. So, this is the Python program for our obstacle avoiding car. For the first part, we import the Raspberry Pi GPIO as GPIO. And from the time module, we import sleep and time. Then, we set the GPIO mode to GPIO BCM and the warning to false. After that, we need to define the ultrasonic sensors and the motor drivers that have connected to the Raspberry Pi. And this is the GPIO setup for the ultrasonic sensors and the motor driver. After that, we need to define the movement for the car. We define the stop, forward, back, left, and right for our car. This is the main function for our Python program. For the first part, we need the ultrasonic sensors to measure the distance. The theory is simple. The Raspberry Pi will control the ultrasonic sensors and send a signal out. When hit by obstacles, it will reflect back and received by the ultrasonic sensors, and this signal will read by the Raspberry Pi. Then the Raspberry Pi will read the duration between the start pulse and the end pulse, and applying the formula to the Raspberry Pi, it can calculate the distance between the car and the obstacles. Then for this part, we program the obstacle avoiding car to move accordingly with the distance. When it is too near, it will go back and turn another way. If no, it will continue to move forward.